Alright, quick change of scenery here. Out of the cafeteria back into the classroom. So, yeah, and the video got split in two, so sorry about that. Hey! Good. So, quick change of scenery. So we're going to take the derivative of this function. But, because it's on the bottom here, the x, we got to use the quotient rule. So that's the derivative of the top times the bottom minus the derivative of the bottom times the top divided by the bottom squared, right? So top here is just the derivative of it, 0 times the bottom, 2 plus x, which we don't really need, minus the derivative of the bottom here, which is 1 times the top, which is 4, okay? Divided by the bottom squared, so 2 plus x squared. Now, of course, I'm kind of running out of room here. What's up? Yeah, it's okay.
Is there a way to turn on the air conditioning network?
No, no, you gotta call Jim.
Alright, I just didn't know how to do it.
Yeah.
Rocket.
So then you get -4 over, then you gotta FOIL this, right? So you get, I don't know, 4 f, I gotta write it like this to be able to think through it, FO plus 4x, I, and then L plus x squared, alright? And, well, from there, you don't need to really simplify this at all. You can just leave it like that. There might be something to simplify there. You might just leave it, it might look nicer actually just written as -4 over 2 plus x squared. I don't know what they would recommend for that. But anyway, suppose that the object is released from rest at the origin. Determine the speed of the particle at 2 meters. Look what I forgot. Negative sign. So this should end up being negative, right? Every one of these has to be negative. I was going to say, better be, right? Because it's got to get pushed off to the positive direction. So anyways, to suppose that the object is released from rest at the origin, determine the speed at 2 meters. So at 2 meters, all right. So if it's released from rest at the origin, right, U equals 2 joules. So that's going to be our total energy the whole time, 2 joules. So then x equals 2, right? U at 2 is 1.0 joules. That means the kinetic energy at 2 has to be 1.0 joules. So that has to equal, because these have to add up to equal 2 joules total. 1/2 of mv squared, 0.5 kilograms, times v squared. So, of course, I don't have my calculator. I didn't leave it downstairs, did I? I hope not. I don't think I did. I think I jammed it in my bag here. Alright. Here's one. I thought I had another one on me too. Oh yeah, there it is. It is in my bag. Alright, so 0.1 times 0.1 times 2 divided by 0.5, which gives us 4. So V equals 2 meters per second once you go through this whole thing. So that works out kind of nicely. In the lab, you're given a glider of mass 0.5 kilograms on an air track. The glider is acted on by the force you determine in part B. Your goal is to determine experimentally the validity of your theoretical calculation in part C. Alright, so from the list below, select the additional equipment you'll need from the laboratory to do your experiment by checking the line to the left of each item. If you need more than one of the item, place it on a spring. So this is funny. Photogate Timer, right? We've never used a Photogate Timer in this class. Most people don't use them anymore. I'm kind of surprised they still put them on here. Most people are using motion detectors and such. You could do it with a meter stick. You could do it with a stopwatch. you're basically just trying to figure out if the speed at the end of the track is 2 meters per second. All right. Photogate timer is your easiest thing because what you can do is measure the length of the glider. Well, see, you wouldn't even know how to do that. Let's see. I would say probably what you want to do. All right. Is I don't, that's an interesting thing. Can you think it's the easiest thing to do is the Photogate timer for sure, right? Because Photogate timer, it's a thing that times how long it takes something to pass through it, right? So you'd say the Photogate timer and the meter stick. All right, and what you would do is photo timer starts when front of what are they calling this, a glider, hits gate. Timer stops when glider exits gate. All right. Measure the length of the glider with the meter stick. Divide length of glider by time in gate. And get the average velocity of the glider in the gate. All right? Then I guess I would say compare
Good afternoon. I apologize
to 2
for the
meters per
interruption.
second.
I am looking for Lightyear Torrent.
That'd be about it.